In this short lecture, I'll be covering von Mises theory, which is something that we're going to be using in a future lecture, and is one of the failure theories we'll be using to predict the failure metallic materials. I'll be fairly quick on this particular topic. There are several failure theories that can be used to predict the failure metallic materials. The most suitable failure theory depends on that particular application, whether the material is brittle or ductile, and what kind of load types you may have, whether it's shear, tension, or you have a combination of loads applied. The maximum shear strain theory or distortion theory, also known as von Mises theory, is a particular theory that's used in a lot of situations where you have actually quite a bit of shear behavior occurring or distortional behavior occurring. According to this failure theory, failure occurs when the strain energy per unit volume reaches a value of shear strain energy per unit volume at the elastic limit in tension. This theory is valid for ductile materials and works best when there's a lot of shear deformation. Here, the form that I'm presenting is in terms of principal stress. There is a form that's presented in terms of the multi-axial stress states that you've seen before, where you have shear and tension applied. In this scenario, I'm introducing to you one where it's only in terms of principal stress. So if you're given a multi-axial state of stress, where you have shear and directional stress components, you'll have to find the principal stresses first, and then you can use the von Mises theory with the formula I provided you here. This is the easiest to memorize, and that's why I like it very much. The von Mises stress can be used to predict yielding or ultimate failure, and it can be basically determined based upon the uniaxial test. So what you could do is run uniaxial test first, which is here at the very bottom row. In the uniaxial test, you will then calculate your von Mises stress. And now your von Mises stress can be used as the criteria for the other von Mises equations. You can use it for the most general version at the top here, which is equivalent to the one here in the second row. The first row is the one that's the multi-axial stress states. But if you were to write it just in terms of principal stress, this is what you get. So these two equations are actually equivalent. And then if you had general plane stress or plane or principal plane stress, these are the two equations. And then if you only had pure shear, this will be your equation. And so the von Mises stress can be set that way, and then you'll use that to then predict failure for a more complicated stress state. So step number one again, you do a uniaxial test to set your von Mises stress. That will then be used to predict the failure using these other theories. Or you do a shear test that will then produce the von Mises stress that way. And then you use that as your failure criteria to predict failure for the other cases, either the plane stress condition or the more general condition. These first two rows are equivalent, and the second two, the third and fourth row are also equivalent. It's just that one of them is written in principal stresses and the other one is not.